Nice and hot. We're going to do the same thing. We're going to locate the outline of the chip. It's kind of hard to see probably on camera, but you can see that the chip is right in here. We're going to cut alongside of it, and we're going to, there we go, here's the pins. Again, keep your angle steep on the knife. You want to remove the epoxy about up to that capacitor. We're only interested in pins 2 and 10 anyway. Also, when you're removing the epoxy at this location, be careful. There are other components located in the board, which I'll show you in a second. Once you got the bulk of the epoxy out, you come back to your non-metallic tool for the in-close work. Alright, once again, you see we've exposed all the pins. We're interested in numbers 2 and 10. And again, there are components located down in here. There's a resistor here, and there's one here. So when you're taking this epoxy off, you want to be careful not to break them. You want to come in nice and steep with the knife. You want to come up under it, and that's it. The third area we're going to open up now is this capacitor. Once again, we're going to heat it. I'm going to shield it with the cardboard. Something like that. You don't have to hold this with one hand while you hit it with the heat gun on the other. You want to keep the heat away from the other components at all times. Excessive heat is the biggest reason these boards are damaged when sockets are being installed. Alright, after we're done heating that area, we're going to make 2 incisions with our little utility knife. We're going to come directly in line with this adjustment right here. The reason is we want to give ourselves plenty of room to clear the epoxy off this capacitor. You do not want to go all the way down to the board. You're going to have to be careful when you do it. You do not want to cut the board behind it, and you do not want to break the capacitor. But the epoxy in this entire area will flake right out, given a little bit of patience. It may even take a second or a third application with the heat gun. But when you're done, this is another one of those non-metallic tools. They're ceramic. It's a little bit smaller. It works much better in a tighter area like this. When I'm done, I'm going to expose the actual point on the board that this capacitor is soldered to. That'll give us enough room to work. All right. I'm being very careful not to scrape the board. There are very small traces down there. If you damage them, you throw the board away. I'm going to give this one more shot with the heat. We just gave it a little bit more heat. We're going to concentrate on getting the epoxy out from all around this cap. Nice big work area, plenty of room to work, plenty of room to breathe, so to speak. All right, I can now see the 2 points I wanted to see. We need to cut this at the right leg, by the way. Nice fine pair of needle nose pliers. You can get in here and clear out the epoxy from between the legs. And if if you can focus in on that, you can see that we've exposed the lighting. Okay. We've exposed the right terminal of this capacitor, nice and clean. I'm now going to get a little pair of dikes. I'm going to cut this lead about a 32nd of an inch above the board, leaving enough room to rejoin the capacitor later, and yet to be able to attach a wire to it now. I'm going to fold it up over to one side on its left leg. I'm going to leave the little stub of the right leg exposed, and then I'm going to throw some solder on it.
Can't see.
Just want to leave a little solder ball here so that you can attach to it in a few moments. The next thing we want to do is we want to tin the pins that we're going to be utilizing. Pin 2 and 10. In addition to that, we're going to pick up power from U9, pin 7, pin 14 on U9, point 00 on the board. There's two little feed-throughs here. Either one of them will do. Just put a little ball of solder on that. We'll be attaching a wire to that in a moment. And then on U31 over here, pin 3. I'm also going to tin up the entire U30.
Can't see.
We're just going to do one pin here on camera, and then we'll pause, because I think they'll get the idea. We'll come back when we do the socket. You just want to... Okay, we've got U30 tinned up. We're going to bend pin 20 over, get it up out of the way on a new socket. By the way, the socket you want to use, you want short pins, pretty flexible, good quality socket. You're going to need two little pieces of jumper wire about 2 or 3 inches. Pin 20, we're going to tack solder one of those wires. Fairly secure. Just make sure it doesn't short out to the sides. Once you've done that, you take your socket and you bend the pins in just a bit, the edge of a table. So that when you're done, you've got about a 20-30 degree angle on them. It keeps it tighter in place when you're putting it on the board. Now it's just a matter of soldering up the pins, one for one. Tack solder your corners to start.
Can't see.
All right, let me get this one started. Don't use too much solder. Apply just enough heat so that the solder flows freely. This will be your physical as well as your electrical connection.
Okay.
All right. All 28 pins have now been soldered, actually 27, because pin 20 is still floating up here. We've got the wire going under to the original chip. We've got the socket pin bent out that we're going to connect to in a second. The first connection we're going to make is from pin 20 to 28. Both on the bottom. And then we're going to take a second jumper from pin 14 we're going to come around and we're going to attach this to the floating pin left on a chip socket. Okay. We've now disabled the original chip and enabled our chip socket. Next, we're going to install the archive device. The instructions are very specific. They want you to install the wires in an exact method. I suggest that you don't not follow them. There are reasons for that. The reasons are so that the board is properly grounded. It's going to be a bit difficult to get on camera because I'm going to be all over the place here. We're going to install the black wire first, providing a ground. And that goes to pin 7 of U9. The second connection will be pin 14 of U9 and red. The third connection will be the green to point 0, 0. Doing okay? The fourth connection will be the blue wire to pin 2 of U19. Connection number 5 is the yellow wire to pin 10 of U19. Connection number 6 is the orange wire to pin 3 of U31. And last but not least, the white wire goes to the little stub we left hanging down here. I'm going to have to lay it down for this, so you'll have to take my word for it. Okay. The device is fully installed on the board. And at this point, in order to keep things a little safer, we're going to put it back in the cage. Next is we're going to install the archive utility chip. This is a chip provided with the archiver. When I use chips a lot in and out, I'll put a second socket in, a short pin socket, so that you're not running the long pins of a standard chip all the way down into a socket and then stressing the mechanical connections you made when you soldered the socket over the chip. This goes in nice and easy. Just make sure your pins are straight. And if you want to take it out, it comes out nice and easy. Here we are, it's all hooked up. We're now going to test to make sure that the board is still intact from all the epoxy removal and soldering that we've done. First thing is make sure that the switch on the archive device is in the off position. Secondly, make sure your Videocipher unit is off. You can connect, well, I use this extension device so that we don't have to work right in the unit. Thirdly, plug the VC2 unit in on a VC channel. Your screen will blank. Check your ID number with setup 1. Record the ID number. All right, we're now going to go through the process of actually extracting the keys. Setup, you can see the menu. Display unit ID, which we just did. Extract 018 keys, display 018 keys. We're going to use those two sections now. The method is to turn the switch on the device, which you saw previously. The indicator will come on. Do exactly as it says. Hit number 2. The screen will flash. You turn the switch off. Hit setup. On the screen, you now see the unit ID number and the 0, 1, 2, and 3 keys. That's all there is to it. It gives you the keys. You can archive them. Protect yourself against whatever may or may not happen. At least you have the information. The board is left completely intact. There is no change in the ID number. There is no damage done to your keys. They are left in the board. There is no damage done anywhere other than the fact that you have made a copy of your keys, which isn't really a damage. Now, just to show you how we disconnect this, we're going to come back to the board. We're going to power down. The wires must be disconnected in the reverse order in which they were connected. The white wire must come off first, then the orange, yellow, blue, green, red, and of course last is the black, the ground. Take the archiver, put it on the side. Do not turn the board on until you reconnect. Let me see if I can get this up in the air for you. You must reconnect your capacitor. Tin the stub you left on one side. Bend it back down. Just solder them up. And everything should be fine in there. The next thing you want to do is you want to remove the archive chip. This is what I told you before about taking out the socket within a socket. It just pops right out. You have two choices at this point. You can remove the wire on pin 28, put a little piece of tape on it and let it hang. That'll enable the internal chip once again. Or you can install a duplicate of the original chip, a stock 018 chip, which does nothing more than make the board function as it did when you opened it up. It's a duplicate of the chip that comes originally in the Videociphers. They're all the same. We're going to now go back to the screen and show that the board is exactly what it was before. Blanked out screen. This board is not authorized. It's a brand new board right out of a unit. Hit setup, number 1, and you can see it's just as it was when it came out of the board, out of the box. Okay. What we're What we're going to do now is demonstrate the cloning process with this new procedure. Previously, we extracted the keys of an 018 board. We copied them down along with the ID number. Of course, at the same time, you would take the monthly information, which is available through a number of different methods. It could be done with the extractor when that's hooked up. You can do it after the board is authorized with the keys are us. Either way, you'll get your monthly information, and you can put that into the chip as well. Let's go through the process now of setting up a chip. Of course, you need your software, which is in the machine. All right, the first thing we're going to do is we're going to load in our program, which is the loader or the RAM. This reprograms the board to the new information. This is pretty similar to any EEPROM programmer you'll find. We're loading in the program now from disk into the buffer. We're going to go directly into the substitute command, which allows us to change the information on an existing file. The ID number goes in first, and it goes in the forward direction as opposed to some programs which require it to be put in reverse. The ID number two bits at a time. This is the information that was previously removed from the board. To the service ID, which is located at 0266, which should be the current month and the A5 authorization in the reverse order. Next, the monthly for this month in location 0100. All right, that gives us our monthly information. And last but not least, we have our seed keys. They go in at location 2000. They go in 7 bytes at a time, and then in zeros. For example, the first key is 4505 0D 62 04 E3 41. That's 7 bytes. Now we put a 00 in there. We continue with our second key. That's 7. 2 more zeros. Oops. We did make a mistake though. Let me back up. More zeros. And now the last key. And of course, we finish off with the 00 at 201F. We get out of there. We set our chip maker up to blow the chip properly. Place the chip in the EEPROM burner and make a copy. This procedure will normally take about a minute as the EEPROM burner loads information into it. You get the verification, the fact that it's okay, all the way through to location 3FFF, which is the last location in a 128K EEPROM. That's chip number 1. The second chip that we have just made is the run chip. And that chip is the one that goes in the U30 socket and stays in there as a final operating chip. It's the Three Musketeer type chip, except it's got a new twist to it. There are no keys and no ID or no monthly information in the chip. All that information is already loaded into the box by the loader chip which we've made earlier. What we're going to do now is take these chips, we're going to put them in a board, we're going to show you how that operates. Here we are back at the board. This is the board we had pulled the keys out of previously. Chip socket installed, jumper wires to enable the socket in place, all of the wiring removed, and most important, before you do power it up, that the capacitor be reconnected down here where we put that white wire before. Connect it up to the Videocipher. Power off, always off when you're making new connections. This is the load chip that we made. Insert it in the socket. Turn the Videocipher unit on. On the screen, you will see plain old Videocipher signal. This is a silent loader. You leave it in here for about 30 seconds. It's doing its thing. It does not give indication, as some other loaders do, where it tells you it's writing data or the screen flashes. You get none of those indications. What it's doing now is it's loading in the monthly keys, the seed keys, the ID number, and all the other good stuff it needs to make this board a copy of whatever we had put into this chip before. All right, I believe about 30 seconds has passed. We're going to turn the power off on the Videocipher. We're going to remove that chip, and we're going to put the second chip we made in, which was the run chip. This chip I do not double socket because it's going to live in this board. Okay, chips in the socket, noting pin polarity, making sure that the keyway is up. Power up the Videocipher. You'll see we have video, audio.
Yeah, smart. I think I overdid.
Setup 1
Not smart at all.
shows no ID number. It's fully secured. It's active.
Now you're
Authorized as an A5.
lively. I smell.
Your location is set.
Smart.
It's truly a cloned board using the keys that we had just pulled out with the extractor.
Energy of an adult. Where do we get the power to create?
It will work on all services that use the A5 authorization. That's the setup 0 screen showing the authorized status, the 24 A5 authorization. The error bits on the audio are where they belong. Everything is functioning as a normal board would.
is that we hook on with our key extraction to archive the keys out of it, the seed keys. Then we remove the battery, install a new one, and then take and reload the 4 seed keys and use 7 over here with the device on this end. And when we're removing extracting the keys, this unit has a pull and a push. When it pulls, it takes a copy of U20 static RAM, holds it up here, and then when we reinsert it, we can put right back the stock static RAM. We do not need a Videocipher signal. As you notice, there is no satellite signal hooked up to this, and you notice when I reinserted the keys, I had the board completely unplugged from the unit. It requires absolutely no power whatsoever from the cage. The case doesn't. This unit powers the whole thing, and it makes it an absolute beautiful tool to replace batteries.
What happens is it works just like a normal box, whereas it has an ID number. It receives the data meant for that ID number off the air. It stores that data